All right, in this video, we're going to do a technical deep dive on how to build out something analogous to the Humane AI Pin or that Rabbit R1 device that just came out. What was the biggest song from 1972? Show me the weather in Vancouver, Canada right now. What time is it right now? How much was GitHub acquired for? How much was YouTube acquired for? How tall is the Eiffel Tower? What's 9,000 divided by 10? What's 4,000 divided by 53? Tell me something I probably don't know.
The shortest war in history was between Britain and Zanzibar on August 27, 1896, and lasted only 38 minutes.
What is the Rabbit R1?
The Rabbit R1 is an AI-powered device that can perform various tasks, including answering questions, taking photos, and placing calls, among others.
What is this image? Before I dive into the coding portion of this, I want to give a quick overview on why I decided to build this out. Before I do that, I want to play this quick clip from MKBHD or Marquez Brownlee here.
Look and tell me what this is. Or I'll just do this, I guess. Ah. It's a Cybertruck.
The photo is of a Cybertruck, an electric pickup truck produced by Tesla.
So if we break down this clip a little bit, so he's holding down the pin, it's recording at that point. Once he releases the pin, it's going to send that photo as well as that audio to an endpoint. From that point, it's going to transcribe what he said. Once it's transcribed, that request is going to be sent with the payload of the image to something like, I would assume, GPT-4. And the reason I'm assuming GPT-4 is because Humane has a collaboration with OpenAI. When I first tested this shortly after when the video came out, I found that the biggest bottleneck was from that vision endpoint from OpenAI. As you can see here, it takes almost 15 seconds to process this simple response, just to get something similar to the response that Marquez had in the video. One thing that I do have to say is from the time that this video was released, this endpoint does seem to be pretty quick. But at times, if say you think about it, there's a ton of different requests going to this GPT-4 vision server, like when Humane releases all these devices to the wild, and everyone's all of a sudden taking pictures of everything, there's going to be a queue to handle all of those different messages, presumably, right? That was the initial bottleneck that I ran into when these Humane pins were rolling out. Ever since then, the inference speed from that endpoint is actually not too bad. It still takes a handful of seconds, but it's definitely not 14, 15 seconds. When I first saw this and I ran into that bottleneck with GPT-4 Vision, I decided, okay, what other models are out there that's able to process vision as well as text? And my first thought was the Llama model. Llama is an open source model. I reached out to the team over at Artificial Analysis and asked them, what's the fastest inference speed for a vision model? They said that they're not tracking it quite yet, but they did point me in the direction of Fal AI. Fal AI offers a ton of different models that you can go ahead and try out. They have a really great website. You can sign up, get some free credits. I've also included their example in this video. So you'll be able to choose from GPT-4V or Fal. The one difference when I was using the Llama model versus the GPT-4 Vision model is the GPT-4 Vision model knew that this was a Cybertruck, whereas when I tested it with the Llama model, it would often come back with responses like, this is a futuristic metallic truck or something to that effect. So there's a little bit of a trade-off. So you might be able to get faster inference speed from something like Llama, but if you want more accurate results, you might be bound to using something like GPT-4V or the Opus Vision or something like Gemini. The other thing that I'm going to be showing you is LangSmith, which is an observability suite from Langchain. This is a product that you can use. There's a free tier that you can use as well. And what this allows you to do is it allows you to track and have these quote unquote traceables in your application. And what you can do with this is you can really wrap any function with a traceable. So if you're using LangChain, you get all of this functionality. If you're not using LangChain, you can go ahead, wrap your function, and pass in the information that you want to send over to LangSmith. As you can see here, there's a ton of different helpful information here. My main motivation of using LangSmith was really to try and iron out all of the different latency portions of the application. So being able to see How long does the TTS take? How long does the image generation take? How long does the transcription take, etc., so on and so forth. Really encourage you to check this out, but it is optional, so you don't necessarily need to use it if you don't want to. Diving into the code portion, we're going to be using Next.js for the front end and the back end. Within the configuration here, you're going to be able to use Groq or OpenAI, and you'll be able to use all of the different inference models that they have available. Right now, we're going to be using Groq. We're also going to be using the Llama 3.8b. You'll also be able to use Whisper on Groq or on OpenAI. I want to thank the Groq team for giving me access to be able to test the Groq Whisper endpoint, which is incredibly fast, which I encourage you to check out. From there, I just have support for OpenAI for TTS right now, but you could swap out this portion for something like 11 Labs or another provider if you like. Then for the vision setting, we're going to have support for OpenAI or FAL AI, like I had mentioned. Then you're going to be able to pass in the different model for the different provider. Here, you're going to be able to provide the function calling provider. Right now, for the function calling capability, I have OpenAI and GPT 3.5 Turbo. Shortly after the video, I plan on incorporating Groq as well. So if you want to use them as well, it's going to be able to just be swapped out right here. Then we also have some Booleans that you can just set on toggling some things within the UI. If you want to enable showing the response times, if you want to show that little cog in the bottom left of the screen, say in the application you don't want to have the user be able to use the speech UI toggle or the internet, you can just turn all of these different things off. Within here, it just gives you easy flexibility on, say, if you want to turn off that speech capability or if you want to turn off the internet results. Say if you don't want to go ahead and reach for an API key from Serper, which is what I have set up for the internet results in here, you can just go ahead and turn that off. And then for the photos, say if you don't want to have an application that's going to be leveraging something like GPT-4v, you can just turn that off here as well, and that will just remove that functionality from the UI. And then once we have that set up, we also have optional rate limiting support from Upstash Redis. And then we're going to have the Boolean toggle for whether you want to use LangSmith for the tracking of all of those different functions that you saw just a moment ago. So first, the project is going to be within the app directory, just like you see here. The main components for the front end are going to be within the page as well as the components folder. And then we also have the tools folder. This is going to be those conditionally rendered UI components that we get back from the function calling. So from there, we're going to be using the Vercel AI SDK and React server components, and all of our logic is going to be routed through this actions.tsx. From there, we're also going to be importing a handful of things from a number of files here that we're going to be leveraging within the actions. And we're also going to be incorporating a handful of tools that are going to be included. This is going to be where we set up things like Spotify, time. For the backend, it's going to be the actions.tsx, and then we're also going to have our utilities folder. So within here, we're going to have a handful of things that we're going to import within here, which we'll be diving into. We also have this optional rate limiting package that you can use here. Since we're going to be using the Vercel AI SDK as well as React server actions, the way that we're going to set this up is we're going to have the action TSX, which is the entry point and the main portion. You can almost think of this as where you would typically have a post request. From there, we're going to have logic that we're going to build out in all of these different components within the utils. Then for the chat completion with tools, which is where we're going to be setting up all that different logic for the function calling, that's going to be within the tools folder, as well as this chat completions with tools. You see all of the different definitions that we pass to the LLM, as well as how to handle all of the different logic to actually invoke those functions once we get the arguments back. That's it at a high level. I'm going to be going over this relatively quickly, but if you have any other questions, please feel free to reach out. Let me know. Open an issue on GitHub. I don't think I mentioned this yet, but you will be able to just pull this down on GitHub. Feel free to fork this, use this however you want, incorporate it into your project, into your company, do what you got to do. Hopefully you enjoy it. Hopefully you learned something. I'm going to go over our backend. We're going to be importing a handful of things. We're going to be setting up the .env. So if you're not using bun, you can just go ahead and include the .env to reach for our environment variables. We're going to set up the logic for Upstash Redis, which is right here. Within here, this is going to be how you can set up rate limiting. Say if you only want users to have 5 turns on this application, you can go ahead, sign up for a free account on Upstash Redis, and then you can just plug in your environment variables, and then you'll be able to plug in the interval here. So if you want 250 requests per user per hour, you can put it in there. More often than not, you'd probably want this a little bit lower, especially on a free tier. From there, we're going to be importing a number of different utilities, which we're going to be diving into in just a little bit. But the way that this is going to work is we're going to be creating this streamable value. What this allows us to do, first we're going to check whether it needs to be rate limited. And then from there, what we're going to do is we're going to get the form data object. This is going to be that toggle as well as the audio blob that we're getting from the front end, and then optionally the image if it exists. Here, we're just going to essentially destructure the different portions of the form data. And then we're going to have a little bit of error handling there just to make sure that we have an audio blob. Since this is an audio first project, we have to make sure that we actually have that. The first thing that we're going to do is we're going to transcribe the audio. I'm going to dive into all of these different utility functions in just a moment here, but just at a high level, first we'll go through all of this. Once we've transcribed the audio, we're going to send that transcription to the front end. We're going to render it on that left-hand side of the screen there. Then what we're going to do is we're going to set up a variable where we're going to start to build out our response text. If it's using a photo, it's going to go through this path. One thing that I'm going to mention here is with the photo capability, it isn't tied to that internet capability. And I decided to do that because I didn't think that having a photo as well as the internet necessarily made sense. Let me know your thoughts in the comments if you think there could be a use case for that. But I found in the example of the Cybertruck, right? If you're holding that and you're asking it what it is, it doesn't necessarily need to do both an internet search as well as triggering that inference from the vision model. But there could be some use cases, right? So say if you hold that button, you say, how much is the Cybertruck today? And then it could go ahead and query that. So that would obviously take a little bit longer in terms of a response time, but you can definitely tweak this a little bit and include that within this logic if you'd like. Within here, we're basically going to detect whether it's using FAL AI or whether it's using OpenAI. So we could even make this a little bit more strict, and then we could use something like this. If it's using OpenAI, what we're going to be saying here is we're going to say, okay, if that toggle is set to use photos, we're going to make sure that there is a photo. Otherwise, we're just going to say, okay, you've forgotten to upload a photo. From there, we're going to go ahead and decide, okay, is it using FAL? Otherwise, just use GPT-4v. From there, it's just going to take that image as well as that transcription of what the user said, and then it's going to wait for that response, and then it's going to send that back to the user. But if we're not using that, we're going to go down a little bit of a different stream. We're going to have the result. If you're using the internet, we're going to have this answer engine utility where we're going to go ahead, pass that transcription to a search engine API and do a quick request on all of the different results for that query. If it's not, we're going to generate a quick chat completion. This is going to be where we're going to be leveraging that Llama 8B model from Groq. From there, we're going to go ahead and see whether we need to invoke any tools. If there's a query like you saw in the example of show me the time or play this certain song, like what's the top song in 1995 or whatever it is, we'll be able to break down all of the different function calling capabilities that we have within here. Then you'll also have to set that up with any chat completion with tools. From here, we're going to be starting to set up the function calling capabilities. So this is going to be where it detects whether there's the intention on if the user wants to see weather data, Spotify data, whether they want to see the time. We're going to have the logic here. We're going to have it within the chat completion with tools, and then it's also going to be within this tools folder. We have these 3 different examples here. We have Spotify, time, and weather, and that's going to be the different tools that you can build out. Over time, I'll add in some more tools here that you can go ahead and play around with. So if there are no tools that are detected, you can just quickly respond back with the message. Then from there, we're going to stream that result back. So that text that we were adding to up here, we're just going to send that back to the client. And then we're going to send back the result. This is going to be what shows on the POM. And then from there, we're going to say, okay, if it's using TTS, we're going to go ahead and we're going to update and send back the audio TTS and call that generate TTS function. The way that I set this up is it's going to send back that result, then it's going to go ahead and generate that audio. So at least you see that text on the POM and you're not waiting and it's not blocked by waiting for that TTS response. Then you just have to make sure that you're calling streamable done. That's just how the Vercel AI SDK is set up. If you have errors or long response times, it's going to be showing you that within the console. And then from there, we're just going to be setting up our initial AI state as well as creating AI. This is going to be how we wire up our AI SDK to make it interact with the front end. It's pretty straightforward, the different functions, but the one thing that I want to call out within these functions is how I set up the traceable. So if I just go into a simple one here, so for the generate TTS, that I'm importing traceable from LangSmith, and all that you have to do to leverage a traceable, you just have to wrap your function with this traceable, and then you can pass in the name of it as well as a bunch of other stuff here. So this is just a really quick example. I'm just really passing in the name of the function. I'll be able to see the response time of all of that, as well as what's being returned in that LangSmith interface that you saw there. Within all of these different functions, I'm not going to be diving into every single piece of these, but they're pretty self-explanatory. So the transcribe audio, what we're going to be doing here, we're going to detect whether it's using OpenAI or Groq. Then from there, we're going to be sending that file to the endpoint. We're going to be waiting for it, and then it's going to be returned. Similar thing with process image. We're going to be sending in that request of the image to GPT-4v, or whether we're using FAL. Similar thing. So we're going to be sending that, and essentially we're just going to be waiting for that text response back. With this answer engine, what we're going to be doing is we're going to be rephrasing that question. Then from there, we're going to be sending that question to the search engine API. And then once we have that response back, that's going to be what we pass within the application, which is going to be essentially acting as a little bit of a RAG application. We're just getting the top results and the summary. This isn't an advanced search. We're not scraping different web pages in this. We're just getting that high level overview of what Serper provides at that top level request object. We're going to be essentially JSON stringifying everything within that and then sending that within the payload to the LLM. So once we have that, we have a simple chat completion at the top, and then we also have that chat completion with tools. I do want to take a quick moment and go over the generate chat completion with tools. So essentially how this works is you're going to have to set up all of the different tool calls within here. So here we have the weather, we have search song, we have get time. And what this will do is it will take that query. If we head back to the action.tsx, you'll see within the response text here that we do have that initial response. I briefly want to touch on one of the unique things that I set up within the application. I have a generate chat completion, which is going to be just querying that Llama 8B 7B model that's going to come back really quick. And then we also have the chat completion with tools. And the reason that I wanted to break this out is I wanted to have each of these be specialized in exactly what they're intended to do. So with the first one, we're going to have the chat completion. All I'm asking for is for a quick response back. I'm not asking it for all of the different function invocations that we're passing in with our tool calls. I'm going to be leveraging a separate model for that. So the reason for that is I wanted to break this out is to essentially have two experts you can think of it as. One is really good at responding really quickly, and then one is going to be focused on that function calling capability. And my rationale for this is as I start to scale out the number of different functions that I'm going to pass into the application, I really want that chat completion with tools invocation to be focused solely on that function calling capability. So right now I'm passing in 3 functions to be invoked, but you could imagine a situation where maybe you're passing in 12 functions or 15 functions. If you start to try and pass in all of that, as well as hopefully get a good quality chat completion from that same model, you might run into some potential issues. I really just wanted to separate it out. So there's these sort of 2 experts you can think of it as. One's really good at just responding quickly to a quick piece of text in a sentence or 2. And then one is able to respond back with this chat completion with tools. And that's going to be focused on the function calling capability. You can dig into some of the backend utilities here, get a look. You can add some in if you just follow this structure. If you wanted to add in a new one, you could just go within here. You could set up another condition for a different tool. You could add it within the chat completion with tools. And then you can add the tool within the import at the top here and then add them below there. But that's just a way on how you can set it up. I might do another video in the future on how to layer in some other tools, say if you want to add in your own tools, so you can see how to do that within how the project is already set up. That's pretty much it for the backend, at least the portion that I'm going to be covering within the video. Check out the GitHub repository if you have any questions or any suggestions on how you think you could potentially improve it. Open an issue, open a pull request. To go into our API keys just for a moment, if you just want that simple transcription as well as the text response, you'll be able to leverage that with Groq as well as OpenAI. So I'd recommend at least acquiring these 2 API keys. In terms of the other ones, if you want to use the search engine functionality, you can get a free Serper API key. If you want to use tracing from Langchain and LangSmith, you can go ahead and get the different keys and values that you need from there. If you want to use rate limiting, similar thing, you can go ahead and make an account on Upstash, go on their free tier, get a free API key. And then optionally for Spotify, you can include that if you want to use that Spotify component like I showed at the start of the video. And then if you want to use the FAL AI Lava image model, you'll just be able to plug that in here. So I wanted to set it up in a way where it's really flexible. If you want to use OpenAI, you can use OpenAI. If you want to use Groq, you can use Groq. And you can swap in the different pieces as you see fit. All right, so to quickly go over our front end, essentially what we're going to be setting up is some of the typical suspects from the React package. We're also going to be using the Vercel AI SDK, like I mentioned. One thing to note on the Vercel AI SDK, if you're using this within a fresh Next.js application, just make sure that you also set it up within the layout here. You see that I'm importing AI from the action here, and then I'm wrapping the application within AI. So back to our page here, we're going to be importing a number of different modules that we made ourselves. We're going to have a screen just to show that it's not mobile friendly quite yet. We're going to show a number of different components if they're conditionally rendered, such as a clock, that Spotify widget, as well as the weather. We're going to have an attribution component, which is just going to say this is using Upstash or Langchain or what have you if you'd like to include. Then from there, we're going to have our input component. This is going to be really largely that first portion of our application. So to set up the application, first thing, if you're using a fresh Next.js create next app, just make sure that you import the AI from the action that we had declared in the backend there, and make sure to wrap your application with this AI component here. We're going to have most of what we have within the application just on this one page here. But the first thing that I actually want to go through is going to be the input component. Then we'll hop back to the page component because I think the input component is largely the bigger part of the application. So if you understand this, you're going to understand 50% of the front end. The first thing that we're going to do within the input component is we're going to use something called drop zone. So this is going to be how we declare those optional images. If you want to pass those to something like GPT-4b or Fowl AI's Llama, that's going to be what we leverage to actually drag that on screen and be able to upload images. From here, we're going to be passing down some props. We're going to be passing down the onSubmit, whether to use TTS, whether to use the internet, whether to use photos, etc. First, we're going to declare how to set up that drop zone. We're just going to specify, okay, here are the different file types that the endpoint accepts. I have it set up for what GPT-4b accepts. You could tweak these for Fowl if you'd like. From there, we're just going to set up a simple button to remove the image. If you're done with the image, you can just remove that and put on a different one. Then from there, we're going to set up the handle recording. What we're going to be using is we're going to be using the media recorder within the browser. And essentially what we're going to be doing is we're going to be concatenating all of that stream of the audio that's coming in from the microphone. And then once the recording is done, so once we've lifted our finger off of that button, we're going to declare that, okay, this has stopped, and we're going to go ahead and submit that data to our action. I'm using form data here. At this point, we're going to be sending through the toggles and the values, those Boolean options. Okay, are we using TTS? Are we using the internet, etc.? And then we're going to be sending that all to the backend. So once that's all set up, we're going to send that audio blob to the backend. From there, we're going to be setting up the form object. We're going to be appending that audio blob. We're going to be including those Boolean toggles on whether we're using TTS, internet, or photos. If we're using photos, we're going to optionally include that image, and then we're just going to send that data to our action on the back end. Then here we just have that simple, fun AI pin here. You can really swap this out for whatever you'd like, or just change the styling. This is just an example. You can take this, you can fork this, you can do whatever you want with it. Right. From there, this is going to be where we actually drag the image onto the screen. And the rest of it is pretty self-explanatory. We have the remove image button, and that's pretty much it for the input component. Just to quickly hop through some of the other components, we just have a simple modal essentially on mobile that's going to render and just show you that, hey, mobile isn't yet supported. That's not something that I've gotten around to, positioning the hand and all of that. I haven't had time to do that yet. But from there, the settings component is also very simple. What we're going to be doing here, we're going to be looking at that configuration object, and then we're going to say, okay, if we want to enable the different aspects of the toggle that we have set up here, whether it's the text-to-speech toggle, the internet toggle, or the photo toggle, and I see a little typo here I'll fix after the fact. We're just going to render those, and then that's going to be what's ended up passed to the parent component and then subsequently sent on that request within the input component. Here we just have a simple attribution component. So if you want to include that within your application, just to point out all of the different great services that you're going to be using. So for our tools, they're all really simple. We have a clock component. It's going to show that second hand every second. So that's what this interval is showing. And then we're going to render the value and pass it in continuously within the clock here. From there, we're going to have a simple iframe button for that Spotify component. Very similar thing with the weather. For the weather component, it's very straightforward. We have live temperature information. We do have mock icons for the weather. Those aren't actually real, whether it's sunny or cloudy or what have you. You could swap those out if you want to put in a different API key. My motivation for putting in these initial tools where that these things are free. The clock is free, the Spotify endpoint is free. You can just make a free Spotify account, get a developer API key, plug that in. And then for the weather endpoint, that is also free. The temperatures and all of that is all going to be dynamic. So now within the main portion of the page, after we go through some of the logic, we're going to be setting up a number of different hooks here. And I also have some things commented out that you can comment back in if you'd like to use them. So if you want the response times and all of that, like a total response time of everything within the application, that's something that I'm still working on. So now within the page, I'm going to run through this pretty quickly. We're going to have the hooks for a number of different things. There's Boolean toggles and the transcript, the messages, whether it's mobile or not, etc. We're going to show the handle click, so actually clicking on that image. We're going to set the toggle for things like the TTS toggle, so whether the internet's on or the TTS is on. We're obviously going to have one for the handle submit. So then for our handle submit, this is going to be how we actually trigger that action that we have set up on the back end. And then this is going to be the main portion of how we actually watch for all of the different responses. So here we're going to declare, okay, if the rate limit is reached, or if the UI component comes back as time, or if the transcription comes back. This is essentially going to be how we route all those different requests within our application to view within the various states that we had previously. And this is going to be how essentially we route all of the different messages within the front end of the application and within the state of our application. So you can play around with this. So if you have new components that you want to layer in there, just make sure that you also include them within this readable value stream with this current architecture and how it's set up. Then from there, we're going to declare all of the different response times. So we're going to have different ones just so we can track things like how long the transcription takes or how long the message takes, how long the total response time is and all of that. Then we're going to have a simple use effect for checking the mobile device. So you can just tweak this as you like. If you want this to be on more of a tablet view, you could bump this up a little bit so it doesn't start to break as much. This is just checking if it's mobile to render that mobile view that we'll have just within the JSX here. If it's mobile, we're going to render that component. Then from there, we're going to have a simple icon. I didn't use an icon library. I suppose I probably could. We're going to render the AI pin within here. I also have a class on here just to make sure that the pin doesn't actually move. I found when you're holding it, had I not added that class and the CSS styles, it would move around a little bit. Then from there, we're going to have our input component, which we had just gone through. We're going to have the current transcript, which is going to render right below our input component. Then from there, on the right-hand side, this is going to be where we render that hand. From here, this is going to be where we have that hand. So we have a lot of things that are just positioned absolute. If you wanted to make more of a serious application, I'd obviously encourage you remove all of that and set it up in a way that makes sense with your UI. But this is just a fun example, right? So if it's Spotify, we're going to render that use Spotify button. The thing that's unique with the Spotify button, I set it up with its own state, so it will be continually there, even with additional requests. So I thought it'd be an interesting experiment to throw it up there if you want to play music while you're asking other things within the application. Then from there, we're going to put the messages on the right-hand side of the hand. And then if things come back like the weather or the time, we're just going to render that within the place of the message as well. From there, we have the option to turn off that settings toggle if we'd like. And then we also have that optional use the attribution component if you want to show the attribution to all of the different services that you're using. That's pretty much it for this video. If you'd like to see something like a Gumroad course or a Udemy course, those are all things that I'm potentially considering right now. For instance, I think with this video, I could probably break it out into 20 different segments, right? And it could probably span over the course of hours instead of just sub 1 hour, sub 30 minutes that I often go through within my videos. There's often complex demos that I like to demonstrate. I'm considering different options on what to pursue next. If you have any suggestions on what you'd like to see, leave them within the comments below. Otherwise, that's it for this one. If you found this video useful, please comment, share, and subscribe. And otherwise, until the next one.